Hi everyone, so this is part 2 of our lecture series on solving systems of equations using matrices. Alright, so in today's lecture we are going to look at examples of how to use the method of reduction, which is what we were introduced to in part 1. So remember that it was reduction. Right, and we will use this method of reduction to solve systems of equations. So before we proceed to that, I just want to repeat the rules that we are allowed to use. So what are the rules? Remember, these rules are called row operations. So what are the 3 operations that I had mentioned previously? So remember, row operation 1 is that we are allowed to swap any 2 rows. Row operation 2 says that we can multiply any row by a non-zero constant. Okay, and the last row operation says that we can replace any row by the sum of itself and a constant multiple of another row. Right, so keep these rules in mind. These rules are fundamental in the method of reduction. Right, so just to repeat, swap any 2 rows, multiply any row by a non-zero constant, and replace any row by the sum of itself and a constant multiple of another row. Right, so what we're going to do now is I am going to go back to the example from our previous lecture. So I'm going to spend time on this example so that you can understand the intricate steps and get a further explanation on how we had arrived at the final solution. Right, so here was the example that we looked at in the previous video lecture. Right, so we had a system of 3 equations in 2 variables, 2x plus 3y equals to minus 1, 2x plus y equals 5, and x plus y equals 1. The first step, and this is important regardless of what system you have, is to rewrite your system in augmented matrix form. So make sure that your variables are aligned, and thereafter create your augmented matrix by writing down the constants matrix. So firstly, look at the coefficients of x. It's positive 2, positive 2, and 1. The coefficients of y, it's positive 3, 1, 1. We then put down a vertical line to denote equality, and then we write down the constants on the right hand side. So that's minus 1, 5, and 1. I'm now going to label each row in this augmented matrix. So this is row 1, row 2, and row 3. And whenever we write down an augmented matrix going forward, that is the labeling that we will be using. Right, so what is the process that we now follow? So remember, we are only allowed to use the row operations that I just mentioned. The procedure that I had described previously is that we need to work with your columns from left to right, and in the first column you need to work with the entry in row 1, column 1. So that's my boxed entry 2. The procedure is that we will now convert 2 into the number 1 using a row operation. So there are 2 row operations that could be applied in here. We could either multiply row 1 by a non-zero constant, or if I find that there is another row in here that has an entry of 1, such as row 3, then I could just swap row 1 and row 3 to get the desired entry of 1, because that is what I require. So since that is plausible in this case, that is precisely what we will do. We will swap row 1 with row 3. So that means that row 2 is unchanged. So let me write down row 2 since it is unchanged. And now let's go ahead and complete that procedure. Swap row 1 with row 3. So whatever was in row 3 now gets rewritten in row 1. So that's entries 1, 1, 1. And whatever was in row 1 gets written in row 3. So that's 2, 3, minus 1. So that's what we've done so far. And here is our pivot entry. Remember, the procedure says that you now need to ensure that you get zeros in the entries in the remainder of that column. So let's proceed to do that. So what I want to now do is convert that 2 into a 0, right? So that's what we are going for. Remember, we already have an entry of 1 in the pivot entry, so that means it's going to remain the same. So row 1 will remain unchanged. And the change now comes in converting the entry 2 into 0. So how will we go ahead and do that? So from our row operations, the row operation that we will use here is that we will add a multiple of the row containing the pivot entry to row 2. So since this entry is 2, that means I need minus 2 times 1. So I need minus 2 times row 1 being added to row 2 to give me 0. That will in turn convert the number of 2 into 0. So let's check. What are we doing? Take negative 2, multiply it to row 1, and then add it to row 2. So minus 2 times 1 added to 2 gives me 0. Repeat the procedure. Minus 2 times 1 being added to 1 gives me minus 1. Minus 2 times 1 being added to 5 gives me positive 3. Right, so this is what we have. Okay, so now we have to continue with the procedure. Remember, the next thing we would like to do is convert this 2 into a 0, but let's just enter row 3 as we had seen it. So I'm not affecting row 3 at this stage. So all I've done is affected row 2. Now let's go on to the next matrix. Right, so now I'm going to work to convert that 2 into a 0. Remember, we have an entry of 1 and 0, which is precisely what we wanted. So that means row 1 and row 2 will be unchanged. So I've got a row 1 will remain the same, so it's entries 1, 1, 1. Row 2 will also remain the same, so it's entries 0, minus 1, and 3. We are now affecting row 3. That entry of 2 must be converted to 0. I need to use a row operation. So remember, we will be using our pivot entry. So what multiple of the pivot entry must be added to 2 to give me 0? It's clear that we need a multiple of minus 2. So I need minus 2 times row 1 to be added to row 3. And that is what we're going to follow through in order to get the rest of the entries. So minus 2 times 1 added to 2 gave me 0. Minus 2 times 1 is minus 2 added to 3, and I will get 1. Minus 2 times 1 is minus 2 added to minus 1, and I get minus 3. So this is what we now have. Continue with the procedure. Right, so if we're continuing, right, so I'm going on to the next page. Right, so we notice now in this matrix that we had just ended off with, we realize that we are now done with column 1, because we have created a unit column. A unit column is a column which has one entry with the number 1 and everything else with zeros, which is precisely what I have in here. So we are now going to move on to column 2. In column 2, which entry do we want to work with? We want to work with the entry in row 2, column 2. Currently, the entry in there is minus 1, and what do I need to do? I need to convert the minus 1 into positive 1. So how do I do that? So remember your row operations, we are allowed to multiply any row by a non-zero constant. And I see that if I multiply row 2 by minus 1, I will get the desired positive 1 in that entry. So I need minus 1 times row 2. So let's do that. Minus 1 times 0 is 0. Minus 1 times minus 1 is positive 1. Minus 1 times 3 is negative 3. And we will leave the remaining rows unchanged. So I'm just copying down row 1 and I'm copying down row 3. So that is all that I had done. Right, continuing with our process. What do I now need to do? There is my pivot entry. I now need to create a 0 above it and a 0 below it. Right, so how do I create a 0 above and below? So firstly, let's copy down row 2, since it already has the desired entry that we want, so it's unchanged. I now need to create a 0 above it. So remember, row operations say that you need to take a non-zero constant being multiplied to the entry containing, my apologies, The row operation says that you take a constant multiple of the row containing the pivot entry and you add it to the row that you're working with. Right, so how do we convert the 1 into 0? What multiple do I need? I need minus 1. So I need minus 1 times the row containing the pivot, which is row 2, being added to row 1. That is what we're going to do. So multiply row 2 by negative 1 and add it to row 1. So that means we've got minus 1 times 0 plus 1 giving me 1. Minus 1 times 1 plus 1 giving me 0. Minus 1 times minus 3, which is 3 plus 1 giving me 4. And we now need to repeat the procedure here. I now want to convert this 1 into a 0. So the same question needs to be asked. What multiple of the row containing the pivot needs to be added to the 1 to give me 0? And I see that since this entry is 1, I need minus 1 times row 2 to be added to row 3 to give me the desired entry of 0. Alright, so let's put that up there. So let's continue with this formula that I've written down. So minus 1 times row 2, so it's minus 1 times 0 added to 0 gives me 0. Minus 1 times 1 added to 1 gives me 0. Minus 1 times negative 3 is positive 3 when added to 3 also gives me 0. And we see that we have now obtained a matrix which is in row reduced form. Right, so we now stop. And the procedure is to now read off your solution. Right, so remember this column represents the variables x, this column represents y, and that's your constant. The straight line represents equality. So interpreting what's written in this matrix, I now have that in row 1, right, row 1 tells me that 1 times x plus 0 times y equals to 4, right? And we then see that in row 2, it tells me that 0 times x plus 1 times y equals to negative 3. Row 3 is a row of zeros, so it tells me that 0 times x plus 0 times y equals 0, and there's nothing useful about that statement. So the only two useful statements are the first two that I've written down. So let's unpack what they now tell me. This tells me that x equals to 4, and this tells me that y equals to negative 3. So what we've obtained for this system is a unique solution. As you can see, there's exactly one value for x and there's exactly one value for y. Remember from our previous lectures in class, we had learned that there are 3 possible solutions that could occur. You can have a unique solution, right? So just to recall, we can obtain a unique solution. So that's 1. 2, you could obtain no solution. And 3, you can obtain infinitely many solutions. So these are the 3 possible cases. Right, and in this case, we have a unique solution. Right, so I hope that you understand the steps in this problem. I'm now going to go on to the next problem. Right, so here is another system, and this system has 3 equations, but let's count the variables. How many variables are in here? There are 4. x1, x2, x3, and x4. Now, when you are solving this one and you're writing down your augmented matrix, you need to be careful, right? Make sure that the variables are aligned correctly. Right, so let's write down an augmented matrix. Remember, we're going to have 4 columns for the variables because there are 4 variables. Right, so notice that x1, there's an x1 in here that should be aligned right here. So let's keep that in mind. So what are the coefficients of x1? In the first equation, it's positive 2. In the second equation, there is no x1, so its coefficient is 0. In the third equation, its coefficient is positive 3. Now let's work with x2's. In the first equation, it's 3. In the second equation, it's a 1. And in the third equation, there is no variable x2, so it's obviously 0. And repeating the procedure, now looking at the coefficients of x3, it's 2, 2, minus 3. Looking at the coefficients of x4, it's 6, 1, positive 6. I'm now going to put a vertical line for the equality and then the coefficients, the constants from the right hand sides. Right, I'm just going to label this row 1, row 2, and row 3. So this is what we now have. Right, so we're going to repeat the procedure. Remember, it's very repetitive. You only have 3 row operations, and your aim is to get this augmented matrix into row reduced form. Right, so we work with column 1 first, and we work with the entry in row 1, column 1. So I need to convert that 2 into 1. That's what I need. So how do I do that? We can either swap 2 rows, or I can multiply it by a non-zero constant. So swapping 2 rows will not work because there are no 1s in this column. So I'm going to have to multiply this row by a non-zero constant, and I notice if I multiply row 1 by half, then I get the desired number of 1. So I need to do that for every entry in there. So 3 times half is 3 over 2, 2 times half is 1, 6 times half is 3, and 0 times half gives me 0. Right, so these are the entries that we now have and we're working with. I'm just going to copy down the next 2 rows. So I'm leaving it unchanged for now. And remember, what is the procedure that we're now going to be following? The pivot entry must be 1 and everything below it must be 0. So fortunately we already have a 0 in that entry, so that means this is the one that we are going to have to change. So let's work with changing that 3 into a 0. So since these are precisely the values we want, let's copy it down because these 2 rows will be unchanged. Right, and row 2, I'm just copying that down. And now we're going to work to change row 3. So remember, the rule that we have to use here is that we're going to take a constant multiple of the row containing the pivot and we're going to add it to row 3. Since this entry is 3, I need negative 3 times the row containing the pivot, and that's row 1, and I'm going to add it to row 3. So we're taking minus 3 times row 1 and we're adding it to row 3. So minus 3 times 1 plus 3 gives me 0. Minus 3 times 3 over 2 plus 0 gives me minus 9 over 2. Minus 3 times 1 plus minus 3 is minus 6. Minus 3 times 3 is negative 9, plus 6 is minus 3. Minus 3 times 0 is 0, plus 9 gives me positive 9. Right, so that's what we've done. And notice now that column 1 is now a unit column. It has an entry of 1 and zeros elsewhere. So we can now move on to column 2. So in column 2, what do we need to work with? We know that the pivot entry is going to be the entry in row 2, column 2, and it needs to be converted to 1. But luckily for us, it already is 1. So that means we do not have to do anything to change it. So let's just rewrite it as we see it. So row 2 has entries 0, 1, 2, 1, 2. So I've copied it down. We now need to make a change to the row above it and below it, because this 3 over 2 needs to become 0, and that negative 9 over 2 also needs to become 0. But let's work with changing the 3 over 2 to 0 first. Right, so what do we need to do? The procedure says that you take a constant multiple of the row containing the pivot and add it to the row that you're working with. Since this is 3 over 2, it means that I need negative 3 over 2 times row 2, which contains the pivot entry, and I'm going to add it to row 1. So now let's be careful and let's follow through with this procedure. Multiply row 2 by negative 3 over 2 and add it to row 1. So it's 0 times negative 3 over 2 plus 1, which is 1. It's negative 3 over 2 times 1 plus 3 over 2, which is the desired 0. Right, moving on. Minus 3 over 2 times 2 is negative 3 plus 1 is negative 2. Minus 3 over 2 times 1 is minus 3 over 2 plus 3 gives me 3 over 2. Moving on here, negative 3 over 2 multiplied to 2 gives me negative 3 plus 0, which is negative 3. and let's leave the last row unchanged. We will affect it in the next matrix that we write down. So I'm just copying down row 3 as you see it. Now let's get out a new page. Right, so now in the next matrix we are going to be working to convert this negative 9 over 2 into 0. Right, so we notice we already have the desired 1 and the 0 above it, so that means we can copy down row 1 and row 2 as we see it. So let's just do that first. Right, and I'm copying down row 2. And now we're going to make a change because we now need a 0 in place of negative 9 over 2. Remember, we are always going to take a multiple of the row containing the pivot. So since this is negative 9 over 2, it means that I need a multiple of positive 9 over 2 being multiplied to the row containing the pivot, which is row 2, and I'm now adding it to row 3, which is the row that we are in. Right, so take 9 over 2, multiply it to row 2, and add it to row 3. So 9 over 2 times 0 plus 0 is 0. 9 over 2 times 1 plus negative 9 over 2 gives me the desired 0 that I wanted. 9 over 2 times 2 is 9, and 9 is then being added to negative 6, so that gives me a value of positive 3. Then we got 9 over 2 times 1 being added to negative 3. So what value do we get there? We then get 3 over 2. Right, repeat the procedure. 9 over 2 times 2, which is 9, and add it to 9, and we get a value of 18. Right, so this is what we now have, and notice that we have indeed converted column 2 into a unit column. It has an entry of 1 and zeros elsewhere. We now move on to column 3. Right, and what do we need to do in column 3? In column 3 we need to work with the entry in row 3 column 3. And what is the entry in row 3 column 3? It's currently 3, which means I need to convert it into 1. Right, so how do we do that? The easiest way at this stage is to multiply row 3 by a non-zero constant. So I'm going to multiply it by 1/3. So that's what we're going to be doing here. So multiply every entry in row 3 by 1/3. I get 0, 0, 1, half, and positive 6. Right, so that's what we get there. And what I'm going to do is I'm just going to copy down row 1 and row 2 as you see it. So here is our new pivot entry, and now we're working to create zeros in place of 2 and minus 2. Right, so let's convert this minus 2 into 0. So that's what we're going to work with first. Remember, row 3 is exactly what we need, so that's going to be unchanged because it already has the desired value of 1. Right, and we're now working to convert that negative 2 into positive 2. So what multiple of the row containing the pivot do I need? Since that's minus 2, it's clear that I need positive 2 times row 3 being added to row 1. So let's perform that. So it's 2 times row 3, and I then take the answer and I add it to the corresponding entry in row 1. So 2 times 0 is 0, added to 1 is 1. 2 times 0 is 0, added to 0 is 0. 2 times 1 is 2, added to minus 2 gives me the desired 0, which is what I wanted. 2 times half is 1, added to 3 over 2 gives me 5 over 2. 2 times 6 is 12, added to negative 3, that gives me a value of positive 9. Right, now we can work to convert that positive 2 into a 0. Remember, the rule is that we take a constant multiple of the row containing the pivot and we add it to the row that we are working in. So since that's positive 2, it means I need a multiple of minus 2 times a row containing the pivot added to the row we are in, which is row 2. So take minus 2, multiply it to row 3 and add it to row 2. So minus 2 times 0 is 0, plus 0 is 0. Minus 2 times 0 is 0, plus 1 is 1. Minus 2 times 1 is negative 2, plus 2 is the desired 0. Minus 2 times half is negative 1, plus 1 is 0. Minus 2 times 6 is negative 12, plus 2 is minus 10. And if you're looking at the matrix that we have now obtained, we notice that this column has been converted into a unit column. Apologies. Right, it's converted into a unit column, and you observe that this matrix that we now have is in row reduced form. So we can now read off the solution. So like before, it did to keep in mind what did each column represent. This represented variable x1, x2, x3, x4. So now let's interpret what this matrix is telling us. The first row tells me that 1 times x1 plus 0 times x2 plus 0 times x3 plus 5 over 2 x4 equals 9. The second row tells me that 0 times x1 plus 1 times x2 plus 0 times x3 plus 0 times x4 equals negative 10. And the third row tells me that 0 times x1 plus 0 times x2 plus 1 times x3 plus a half times x4 equals positive 6. So this is the system of equations that we now have, which describes the solution. Notice that x1 and x3 are in terms of x4. So to make this more clear, we can rewrite this as x1 equals to 9 minus 5 over 2 x4. x2 is just as it is. And x3 is equal to 6 minus a half x4. So now it's more clear, and you can see that x1 is indeed in terms of x4 and x3 is indeed in terms of x4. So what this means is that for every value of x4 that you're going to plug in, you will obtain a new value of x1 and x3 respectively. And there are infinitely many choices for x4, therefore there will be infinitely many answers for x1 and x3. And similarly, when it comes to writing down your solution, there will be infinitely many solutions. Alright, so this is infinitely many solutions. Let's make a note. And we see that since we can substitute in infinitely many choices for x4 to determine new solutions, it's wise to write this down in terms of a parametric solution. So what we do is we let x4 equals some parameter t, where t is a real number. And then we see that therefore x1 equals to 9 minus 5 over 2 t. x2 is just minus 10. x3 is equal to 6 minus a half times t. And of course x4 is t. So this now becomes your solution for the system that we were solving. Right, and this is where I'll end.